We have Bob Friday, VP and CTO at Mist Systems, a Juniper company. Welcome, Bob, to the Data Exchange podcast.
Yeah, thank you for having me, Ben. Great to be here.
So I know you folks are doing a lot of interesting and quite challenging things in machine learning, AI, and data infrastructure. So to set the stage, Bob, let's first describe the use cases for data science and AI and big data at Mist.
Yeah, so Mist is focused in kind of the networking space. And one of the inspirations for Mist was, if you remember Watson playing Jeopardy.
Yes.
Our mission here is really seeing if we can't build something that can answer questions and managing networks on par with human domain experts, right? And so that was kind of the original vision at Mist, and that's what we've been working on for the last 6 years or so.
And so, Bob, for the people who don't follow networking, so what are the data sources and what kinds of data are we talking about?
Yeah, so when you look at Mist, when we started, really the question we were trying to answer is, why are you having a bad Zoom experience? Why are you having a bad internet experience? So when we started Mist, we started on the wireless side, the Wi-Fi access point. It turned out that about 80% of the data we needed, we got from that access point. Now, as we've joined Juniper, we're starting to expand our data sources from the access point to the switch, to the router, even to the client now, where we basically ingest data from all these devices. If you kind of visualize anything between you and the internet or the cloud, we're starting to pull data from all those different sources that, as your packet moves from the laptop to the whatever the application is you're trying to get to.
So it sounds like so just generally network quality and in infrastructure, the health of infrastructure. It seems like you have the classic ingredients of what we used to call the 3 V's, right? So volume, velocity, and variety, particularly volume and velocity. So how important, Bob, is the technical foundational layer for the rest of what you do? So in other words, before I imagine before you do anything interesting, you have to be able to collect, ingest, store, and kind of clean the data, right?
Yeah, no, interesting. When we started Mist, before we even could get to AI, we probably spent 2 years just getting the cloud infrastructure built up. And one of the reasons I left Cisco to start Mist was really what I noticed is, okay, if you're going to do stuff in real time, like if I want to process data in real time, you've got to have all the pipelines in place, right? You got to have Slack, Flink, all those real-time processing to get done. So that was like a 2-year process, just getting the cloud built, the infrastructure, the pipeline, so we could actually ingest data from all the networking elements.
And what kind of volume of data are we talking about?
Right now we're talking about like 200 terabytes a day. So you can kind of think about, if you look at a networking devices, we may have maybe at this point we have 500,000 AP switches and routers out there across our customers, sending us data back every minute or every second, right? So we have constant data flowing back at us from 500,000 networking devices and growing out there.
So before you even get to machine learning and AI, I imagine you have to kind of have some basic applications like dashboards and business intelligence and things like this. And so what about challenges around data quality and things like this? So do you guys have to address any of these?
Yeah, the interesting thing, what we found when we started the exercise is we actually tied our data science team to our customer support team, because you had to make sure that you had the actual data needed to answer a question, make sure we could get that to the cloud. And so that was kind of the first step in the process, is making sure we had the right data to answer the question in the cloud.
So at what point, Bob, so you spent 2 years, you said, building that foundational data infrastructure in the cloud. So what were your first initial projects in machine learning once you got all of this in place?
Yeah, I think the first thing, I wouldn't even call it machine learning, it was almost data mining, was mutual information, right? So we basically had created a framework that basically could allow us to apply mutual information, where you can take one random variable, like why did the customer have a problem, and basically correlate it with a network feature. So that led us to start to solve problems like, hey, if you have a robot in a distribution center that's acting up, we could start to isolate it down to the OS type and the driver type, right? And that's this machine learning. So that was kind of the first thing, what we called SLE metrics. And amazingly, I will tell you, what we learned right off the bat was customers just appreciated having the data in the cloud. Getting the data into a framework that you could apply an ML model, that alone, customers, that was, because that was the first time they didn't have to go to the device. They actually had the data. So that alone had a lot of value to our customers when we started.
By the way, I've been involved in many surveys across the data and machine learning space, and I think one of the key things that keep always emerges is that the people who seem to succeed are the people who did what you did, which is basically invest time on that foundation.
Yeah, the interesting thing I would say, I've done several startups in my career. Usually when you do a startup, you usually have to kind of stop what you're doing when you scale the business. The interesting thing at Mist, we built the actual cloud foundation. We still have the same cloud architecture we had when we started. And that's all due to the fact that we did the upfront work and spent the time making sure we had a very scalable foundation to build on top of.
So in the area of network quality, Bob, is location data another piece of information you guys collect?
Yeah, the interesting thing, you look what we did, we solved the network problem, but interesting, it turns out almost all our B2C customers, hospitals, hotels, retail, those are all about customer experiences. So part of our problem is really around location. And interestingly, that was probably another one of our very first machine learning algorithms, was really how to learn what I call the path loss model. This is basically how to correlate RSSI worth of distance, and that's different in every building type. And that was actually the very first thing we did, is build this virtual BLE machine learning algorithm that would basically automatically calculate the path loss, so you didn't have to do any fingerprinting, right? We didn't have to have people gathering around collecting labeled data. And you think about it, that's really what people used to do. That was basically people walking around collecting labeled data for their models to work. So we got rid of that. That was one of the first things we did here.
So are you saying this model's unsupervised?
Yeah, this is an unsupervised machine learning model that basically will learn the path loss, which is the relationship between signal strength and distance for a location engine.
Do you I'm curious, do you folks use any kind of graph technologies like graph databases?
Yeah, we're actually just starting. We actually have a big graph database now for all our devices that basically uses it, to start to do the graph neural networking. The first application we're working on really is what I call temporal correlation. So now we have a graph of where the packet goes between, the device and the cloud. And the first thing is to try to solve the problem like configuration changes. If you ever work in the networking industry, it turns out that the configuration changes are usually the root cause of a lot of problems, where you shoot yourself in the foot.
By the way, give us an idea of the size of your graphs, nodes and edges.
I think the sizes right now, we're up to millions of nodes with thousands of edges because of the clients. If you think of a network, right, we may have thousands of nodes in the network, but the clients could almost have a 10-to-1 ratio, as you can kind of visualize the graph going out. For every access point, there could be 10 clients attached to it. And it's very dynamic, right? The network itself is pretty static, but the clients are constantly changing in the graph.
So I would imagine, so we're talking quality, service levels, and things like this. So I would imagine anomaly detection would be something you folks would be interested in.
Yeah. Anomaly detection was an interesting journey for us. I mean, we started anomaly detection, we kind of started with the moving average. Then we went to this ARIMA.
That's good enough in the beginning, right?
Yeah. Well, it turned out ARIMA was not good enough. I mean, when you do anomaly detection, especially in networking, IT guys do not like to be woken up at 3 o'clock in the morning.
False positives are not a good thing.
So it really wasn't until we got to these LSTM models where we really got anomaly detection with low enough false positives that it was useful for an IT person, right? It's like we got the false positive down to, a couple of percent where, hey, if you see an anomaly now, it's worth making attention to. And for those who are familiar with LSTM models, the big thing was really you're predicting multiple dimensions, right? You're predicting both the average value and the confidence window. And so that was kind of the magic of these. And it's probably a great example where deep learning actually made a difference in our networking industry space right now, where deep learning makes a difference inside of networking.
So, so because you're using LSTM, I'm assuming it's not something you train that frequently, right? So, so at what do you think you'll get to the point, Bob, where you will need models that can be trained more quickly than LSTM?
I think we'll get that. I mean, right now, even our LSTM models, right? We have every site has an LSTM model. So we have like 25,000 sites. Those 25,000 models get trained every week on the last 3 months of data. So every week we update the model for every site in the network.
And because because I've played around with LSTMs for time series, and one thing I found was they're kind of slow, huh?
Yeah, well, I mean,
to train. So
yeah.
and then I guess there's these new things, the temporal convolutional networks that are starting to become competitive, that might be faster to train.
Yeah, and that's what we're looking at. And I think that's the same thing, on the graph side. Now we're starting to look at, if you think of a graph as kind of an image with the edges, the question is, can we start to use convolutional techniques on networking data? Can we take the networking data and make it look more like an image, where you can start to apply convolutional techniques to it?
So you folks spent some time building your foundational data infrastructure. I'm curious, what sorts of tooling and tooling and infrastructure do you have now for ML? So now you have ML ops tools that include, the model server, experiment tracking, feature stores. So are you starting to dabble in any of these?
I would say we're dabbling, but I would say for the most part, we built all those tools. A lot of those tools we built ourselves.
Because they weren't around, probably, right?
They weren't around, and I would say in our case, it's more about what I call digital twin. Right now we basically have what we call a staging network that basically reflects our production network. So everything goes into the staging network. Now there's a whole set of continuous integration test tools that go through every time we check in, whether it's a model or code. Every time you check something in, it has to go through continuous integration test to get checked out. So I would say that's probably the biggest part of bringing this thing to life. I would say the machine, I think we talked about this, right? The ML model by itself is probably the simplest piece of the puzzle.
Yes.
In terms of trying to scale this for production. If you look at the day of the life of a data science, the model itself is the smallest piece of the problem right now.
Yeah. So Bob, talk to me about the staging environment. So the staging environment is kind of a mirror of what's happening in production. So if I have a new model, I push it out to staging, and so then so then do I start getting metrics around performance of this new model that are mimicking what's happening in the real environment?
Yeah, I mean, this kind of falls, if you look at cloud vendors like Google, Netflix, this kind of follows the cloud model. Usually you go into a staging, digital twin, then it goes into kind of like a small subset of customers, right?
Yeah. Like what do is it called? Canary deployment?
Yeah, canary testing or red blue testing, but that's kind of the classical way of releasing things into a cloud environment. You start in staging digital twin, bring it into a small set of scaled customers, right? Because that starts to test scale, right? Making sure nothing breaks at some scale, and make sure things still work and nothing has changed. And then you start to open it up to a larger set of customers, cloud customers.
So we know that models, once you deploy them, you have to retrain them, like you folks retrain them once a week. Have you had situations where actually something went wrong in between those two regularly scheduled events that you had to diagnose what happened and then push out a fix earlier?
We haven't had, I mean, we haven't had that happen. What typically happens is you don't pass staging. Something goes into staging. There's production pushes every week, you know, and usually what typically happens is you'll catch it in staging and back it out. It's like if it doesn't work in staging, you back it out there. We haven't had anything really get into the wild yet where we've had a major bug or major break, a model situation where a model breaks out in production.
So how do you folks what's your tools around collaboration so that people can collaborate across maybe even teams? Like you have data scientists collaborating with data engineers, collaborating with DevOps. So what's your tooling to enhance collaboration?
No, the amazing thing is you've probably seen with engineers, right? They can be sitting across the table from each other, and they would prefer to Slack each other than talk to each other. So I say Slack is probably the preferred tool of the engineering team right now in terms of communicating. I would say probably the more interesting thing is we found is, to make this whole thing work, is we had to basically tie the data science team right to our customer support team. And that was probably the other thing I found kind of going from a big company to a small company is organizationally, you have to get the domain experts tied to your data scientists. And that was probably one of the key parts of our success here that, every support ticket that comes into Mist right now, we basically use Marvis to answer that ticket, right? Because, if you think about us, we are basically a gigantic service provider. We have visibility across all our customers right now.
And for our listeners, Marvis is
our AIOps engine. That's basically our AI assistant. That's what our customers use basically to help them answer and manage questions on par with the domain experts.
But this is a conversational, a chatbot.
Yeah, there's two components to Marvis right now. One is what I call a conversational interface, which is really around troubleshooting problems. There's really another self-driving actions where we have customers who are now letting Marvis generate support tickets or make changes to the network automatically, right? So if you look at it, there's two dimensions. One is, if Marvis can figure it out, let Marvis fix it. If Marvis can't figure it out, Marvis helps you troubleshoot and get to the data you need to solve a problem.
So if you were to take Marvis and point it to a different area, so how much data does it need in order to provide value?
Well, I mean, if you look at the top of the pipe, right, you kind of think of a funnel. At the top of the pipe, we have 200 terabytes of data coming in every day, right? At the very bottom of the pipe, out of that 200 terabytes of data, you may have, 3 or 4 actions, and that's kind of the filtering that's going on here, right? Trying to get down to actionable events, right? Something that an IT person needs to take care of. And that's the paradigm shift of generating tons of events that there was too much noise, and that's what we're doing with AIOps, right? We're basically taking all those events and trying to filter it down to some insightful action that an IT guy cares about.
So, so there's two metrics that, as you were talking, I started thinking of two metrics: precision and recall.
Yes.
So you can have very high precision, but how do you know you have good recall?
Yes.
How do you know you're not missing something?
Well, I would say there's always I think right now the thing is more about making sure that when Marvis gets a correction, that it's 99% accurate.
Yeah, right.
Which is more important than actually missing something now.
I see.
Right. And so I think if I look at I think the other metric, if you look at our support team right now, just on the troubleshooting questions, there's usually two types of questions, troubleshooting and kind of questions. The troubleshooting side, we're at 70%. So 70% of the time, Marvis can basically solve some problem, which is probably our big metric right now is how close are we getting to playing Jeopardy level networking championship? How close can Marvis actually perform on par with the network domain expert?
And so the remaining 30%, is there a way to describe what characterizes that remaining 30%?
I mean, usually what happens, like in our support team, right? They'll use Marvis to try to answer a question. And that'll usually come back. If that doesn't come back with an answer, Marvis will typically come back with the data, most relevant to that question. And so that's probably the other paradigm shift of, if I look at conversational interfaces and NLP, I think this is the new user interface, for networking in other industries, right? We're kind of moving from the CLI dashboard into this conversational interface to make it much easier to get to the data you need to get to. So either you get the answer, or Marvis gets you to the data that's, gets you closer to the answer.
So so does Marvis provide you a link to the data? So how does that work? What's the UI for that?
I mean, so the UI for that is basically Marvis will provide you the top three most likely causes. If you're basically saying, hey, why is Ben having a bad Zoom experience? It'll get down to, well, it looks like he's either got interference on his Wi-Fi, he's got congestion on his router. These are the three most likely reasons for Ben having a problem on a Zoom call.
And then as you guys gather more and more data, the answers that Marvis supplies gets better and better, right?
Yeah, I mean, I think if you look like where we started the journey with the Wi-Fi access point, that gave us, we could answer a lot of questions about why you're having poor connectivity problems. Now that we get the data from the router has a lot of visibility into the sessions and the applications, right? So lets us start to answer more questions about, why is Zoom or why is Teams having a problem? And it starts to let us answer more questions of more granularity, right? As I start to get data from switches, I start to understand exactly what went wrong in the switch. Did the VLAN get misconfigured? And then I can start correcting it, right? If I have control of the switch, Marvis can actually fix the VLAN if it got misconfigured.
So, I'm not sure if this is something you've thought about or something that you guys grapple with, but this notion that machine learning, while it's great, there are areas where domain knowledge could help. And if you subscribe to that belief, how do you folks combine machine learning and domain knowledge?
Well, I think, as I said, between the support team and data science, because for me, I think people confuse the fact that, AI is usually the concept of doing something on par with a human. There's a lot of things we solve with ML, right? I mean, ML has been around for a long time. We solve a lot of problems. I think the big transition is, are you really doing something on par with a human? Are you really building something that's going to be on par with a human? Which really comes down to domain expertise, right? We're basically trying to take domain expertise and stick it into Marvis. We're trying to build something that actually does something on par with a network domain expert, right?
Yeah, because sometimes, so I'm not sure if this is the case in networking, but there's areas, for example, in industrial applications where maybe you just don't have that many anomalies because the equipment is super, super reliable. And so, but the humans might have some level of expertise where you can build an initial system that's mostly human knowledge, and then over time, the machine learning gets better and better, right?
Yeah, no, I'm a big fan of what they call human-assisted AI.
Yeah.
This is kind of like, the robot in your house. You've got a robot in your house, and all of a sudden it gets stuck in a corner case, right? And basically, and I've seen, I think there's a startup there that does is, the robot will call back for human assistance, right? If it gets stuck in a corner or something. And I think that's what you're talking about, is more of a AI assisted where the human domain still, solves the corner cases. You use AI to solve 80% of the problem, but there's still 20% of the problem that requires some domain expert. And to some extent, that's what we're doing with Marvis, right? Marvis solves about 70% of the problem. 30% of the time, we still need a domain expert to come in and help push it over the finish line. So
what directions are you looking forward to, Bob, in the next 6 to 12 months in terms of things that you and your team will push out, or things that you and your team will investigate?
Yeah, I mean, we talked about a little this earlier, was, I think right now, NLP, conversational interfaces, for me, for a virtual assistant to really become a trusted member of a team, you need to be able to interact with that assistant, right? As you would a normal person. And so getting that whole conversational natural language thing down, we're investing a lot of energy on that, and to help Marvis become a trusted member of an IT team. The other thing we're starting to work on is the other thing that's kind of natural in human behaviors. As you hire a new intern or someone, they get trained, they get better over time. I think that's the other piece we're starting to work on right now with Marvis is how do we bring back that domain expertise feedback, so we can transfer domain knowledge into Marvis. How does Marvis really learn from an IT domain expert that is interacting with it on a daily basis?
Right. So how do you do that in a principled way, right? So
Yeah, it's easy to do when you think about training, but you think about continuous, how do you continuously improve the actual algorithm with human interaction?
So, is reinforcement learning something on your radar? It sounds like it could, because of the nature of your data, it could be potentially something worth investigating.
Yeah, I mean, so we use reinforcement learning, what we call network radio resource management. So that's one application where we actually use reinforcement learning, and it's really about taking the user experience as that reward. Now that we have actual visibility of the user experience, you can start to adjust the power and the channels on the radios now to kind of optimize that user. And that's kind of the word. As the user experience gets better, you can kind of learn what's the right channel and power assignment that optimizes the user experience metric.
And you had mentioned something about graph neural network. So what are you folks planning in that area?
I mean, I think we talked, that's where we're starting to look at, can we leverage the power of all the convolutional? We got LSTM kind of solving kind of the time series problems. When you start to look at networking as kind of an image, right? If you look at in a graph, where we have switches, APs, and clients, you can kind of start to see if you see something disconnected, you can treat that like an image problem, right? You treat each little node as a pixel, and the edges are basically giving you information of what's connected to that pixel, right? And that's kind of what an image is, right? You got pixels and you got pixels near it. And that's what the graph brings, right? It brings that topology into the thing, which kind of lets start pushing down the convolutional graph neural networking path.
Yeah. Actually, the graph neural network, the reason I bring it up, it's a couple of great use cases that seem like they are right up your bailiwick. The first one is recommenders. So people are starting to investigate it for recommenders, and it sounds like some of the things you folks are doing are kind of in that realm. And then the other one is I know that some people have had some good success around graph neural networks around traffic, traffic prediction. Like I know DeepMind has worked with the Google Maps team to improve kind of real time estimated time of arrivals, for example.
Yeah, I saw that one, right? They're starting to be able to predict the traffic jams, right? You leave, they're starting to look into the future and say, yeah, you better add an extra 10 minutes because by the time you get to that intersection, it's not going to be as it's going to be a little more crowded than it is now. So yeah, that's perfect. It's the same sort of traffic pattern, right? If you look at the networks, they kind of look like traffic, streets and highway thing. You got a bunch of little streams all going back to the WAN router turns to be the bottleneck and everything.
So in closing, sometimes we in industry, we over focus a lot on tools, right? So tools, models and infrastructure and things like that. But when we last talked, I know that you have a lot of strong opinions and also a lot of good lessons and best practices for our audience around organizations and best practices for data and AI teams. So, anything you want to highlight, Bob, in terms of lessons you've learned in terms of in your career, in terms of how to organize data and AI teams?
Yeah, I mean, I think on the Mist venture, I mean, the one thing I would kind of recommend if you're headed down the AI path, the first thing you really want to start with is try to answer the question of what human behavior are you trying to mimic? If you're building, are you building an AI solution or just an ML algorithm? Once you get that down, that kind of really defines what data you need, because that kind of leads to make sure you know what question you're trying to answer. And then organizationally, I would say my experience would be, between data science and domain expertise, organization is almost as important as the architecture. You got to have that right cloud foundation, set to actually collect and process data. But organizationally, you got to make sure you have the data science and domain experts kind of organizationally aligned to work together to solve problems. And that's what we've done here is basically, it's not just modeling, data science here lives from cradle to grave. They start with the customer, the problem, and then they basically have to, at the end of the day, verify they've actually made a happy customer.
Right. So how do you really move the needle in terms of the business and prove business value,
Yep.
as opposed to just tweaking and tuning models all day?
Yes. Yeah, at the end of the day, someone's got to care that your model actually did it do something useful that the customer cared about.
And by the way, as we discussed previously, many cases actually the best investment of your time might be working on data problems, not model problems.
Yeah, as we said before, for me, it's like anybody who wants to be a data scientist can become a data scientist in 3 days. I mean, you can be up and running and training a model, in probably 3 days. Almost all the work around this AI data science stuff is really around feature engineering, data pipelines, and getting all that stuff correct before you can even actually get the model, up and running. So for me, the model is like the smallest piece of the problem, when you're actually trying to get something in production working.
So when you onboard a new data scientist to your team, you kind of set out the expectation that hey, in this place you've got to build your own pipelines, you got to work with business users and domain experts, and you've got to just not expect that you're going to be building models all day.
Yeah, if you go through an interview here, there's kind of the typical, do you know your ML, math and theory? But the other big hurdle here is really around, how good of a problem solver are you? Can you actually work with customers and customer support and actually understand the features you need to solve a problem? Do you understand the problem, right? Can you actually understand the problem that needs to be solved before you even start the modeling process? And that's actually harder than you think.
Hey, one last thing I forgot to ask you, which is we talked about conversational assistants in Marvis. Do you envision a point where you're also going to be looking at speech and voice?
Yeah, interesting. That's a hard problem because I've actually looked at that and kind of like meeting summarization problems, and just getting the speech to text problem. That's by the time you look at the speech to text, it's got so much noise there.
Yeah.
Let alone solving that problem. That's a whole nother piece of the puzzle that needs to be improved upon.
Right. And with that, thank you, Bob. And super exciting. I mean, because basically what I love about what you guys are doing is it's basically the scale and the immediacy, and also kind of it's the kind of thing that you can't really make a lot of mistakes because there's network quality. A lot of people require very reliable networks, right?
Yeah, I mean, this has been, I have to say, of all the journeys, we're getting closer to this Jeopardy Networking Championship. I feel like we're almost there. We're at 70%. I feel like in the next couple of years, we will be at 97% playing Jeopardy on par with these networking domain experts.
Thank you, Bob.
Okay. Thank you, Ben.